Nature provides us all the evidence we need to enclose the most with the least. Hi, my name's Sam Lanahan. I'm the inventor and founder of FLEXTEGRITY, and I'm here today to introduce to you the C6XTY line of structural fabrics. Structural fabrics are derived from a synthetic lattice that I invented that can be made flexible, lightweight, and porous for a variety of applications that require resilience, strength, lateral integrity, and reduced weight. Synthetic lattices are based on the geometry of the fullerene, or the carbon-60 molecule. The carbon-60 molecule is familiar to all of us because it is the pattern that's found on the soccer ball. The sphere encloses the maximum volume for the least amount of surface area. Because spheres operate very well in compression, so the forces are in towards the center. Can we take that and then align that, array that in a sea of tension? And what would that look like?
A core idea in tensegrity is that the compression elements, they don't touch each other. They're held in suspension by very tight wires. This is an extremely stable and rigid structure. Now, take that same idea and apply it to a lattice, something that repeats endlessly through space, and that is very much the lattice that Sam Lanahan is working on in the form of the various versions of FLEXTEGRITY. Alexander Graham Bell. After the telephone, he got deeply into something he called a kite, which turns out to be the very same lattice that Bucky Fuller called the octet truss. Fuller, he had always been involved in studies of tension and compression. He had a completely different perspective from the architects. He was thinking in terms of how heavy is this building and how can I make it lighter? And the answer was use more and more tension.
This discontinuous compression, continuous tension concept, the islands of compression in a sea of tension. These are Fuller's very words, and we can see that expressed in this, what I now call a structural fabric. It could be made from any size, out of any material, plastics, metals, ceramics. It could be actually grown. And in fact, the whole system lends itself very nicely to a fully automated processing.
What's characteristic about this particular set of lattices is how the individual compression members are connected. Buckminster Fuller and other architects tend to go directly from the center to a neighboring center in a straight line, whereas Sam has always brought a curved approach to tensegrity to create new properties and new lattices that we have never seen before.
The configuration of the tensile elements between the compressive elements are springs, more spring-like. By changing the properties of the interconnecting elements in this instance, we've made this same, what was then a flexible material, into a stiff material. And so if you were making a smart street, the street may have a little bit of resilience to it. The other property that you get is its porosity. So rain's going to go right through it. We can certainly put heating coils in certain layers. We can put lighting in certain layers. We can put information in different layers. We can build all of our bridges. We can build our infrastructure in such a manner that it's resilient in an earthquake and it's not going to collapse. This is how we want to build the next generation of resilient structures. Now, that's all achievable with a synthetic lattice.
Atoms, all our little compressive things that we think about as creating the universe, don't actually touch each other. They're held in electrical fields and so forth. So for Fuller, tensegrity was kind of a metaphor for how compression and tension work together in general everywhere in the whole universe.
It's the death of compression. We've stabbed compression. We're no longer going to build in compression any longer. We're going to build in tension the way nature builds. It's doing it in the most efficient manner possible. We just need to sit and get out of this idea that we're going to engineer the solution. In most cases, the solution has been provided to us. We just need to take the time to study it and understand it.